Hello, good morning. It's our course projects for the simulation class in LAMAR University. My project is basically entitled Arena Simulation of Single Piece Flow for Building Knife Gate Valve KGV. So the two keywords for this project are Single Piece Flow, SPF, that's what we mostly refer to in this project, and the Knife Gate Valve, which is KGV. This project, in summary, took about 192 hours. If I can jump into the slides right at the end, it basically shows that we have spent a good amount of time in understanding the project concept, the design, the details, the modeling, the detailing, and the need sometimes also to do the 3D, three-dimensional floor plan that helped us a lot in the arena simulation. We explained what's KGV and what's really the background behind it. Not to extend the talk longer, the outline for this presentation will basically talk about the background and basically an introduction for the topic, some objectives and key objectives for this basically projects. What are we trying to achieve? We will talk about the KGV, the knife gate valve manufacturing methodology, following the steps that we need to follow for arena model simulation and animation, and then ending up with basically a conclusion and results. Basically, to make it very short, the competition that was brought from the European markets had impacted a product called a knife gate valve, KGV. It was offered almost at 25 to 35% in lower prices compared to the domestic manufacturers, like Kickley manufacturers, which is the company that we focused our project on. So lower prices, and at the same time shorter lead time, meaning it takes 6 weeks to deliver basically the KGVs, the knife gate valve. What's KGV? KGV is basically used in power industries to basically control the flow of coal in generations of electricity. So it's a product. It's a very key product in basically controlling the flow rate of coal for the power generation. The objective of this project is basically to improve the quality index for this product, which we have explained a lot in the report and saying what are the parameters that we are concerned about. The lead time, meaning in order to compete with the European products, we need to improve the lead time. We need to increase the productivity and the manpower and its cost savings too. And we need to reduce the inventory cost. And that's something we will be also touching on as we go through the process. We will also improve the quality and fewer defects. What happened is, when we talk about single piece flow, just a quick overview of the single piece flow, as we've seen like in our reports. The single piece flow can be described as some kind of a state that is really most efficient in manufacturing. Compared to batch sizes and lot productions are basically replaced with a single piece flow. Single piece flow means working on one product at a time. While not, basically practical in some cases, that's why you feel that the single piece flow is basically a clear implementations of lean manufacturing. A prerequisite for this topic, for the single piece flow and the KGV, is a good thorough understanding of the lean manufacturing concepts by basically reducing some of the key wastes that we learned in previous courses, like labor, like overproduction, like space, like defects, unnecessary human motions, inventory, transportations. All these are in our basically simulation model in order to represent what could be basically ideal. So the process of manufacturing this product, the knife gate valve, will go through operations and stations, welding, turning, assembly, testing, milling, integrations, And at the end, what we're trying to achieve is to improve again in quality, lower less space, identify the basically these lean terminologies that we also explained in the report, the Kaizen workshops, and so on. So basically, what we have here is that the knife gate valve, we've showed in one of the slides, basically the detailed components and the place of each operations. That shows the weldment part here, and they showed me the electrical portion, the hydraulics, the sealing, the fastening. All these operations need to be taken into considerations to improve the quality by reducing the time used in each workshop or in each station responsible for producing such part. So that's something we have already covered, and we said that this product is really important in the power industries because it really isolates the pulverizers from the feeder. It's in the middle. It's you look at this KGV as something between two stages. The pulverizer, where the coal comes and it gets crashed, it goes through this KGV and then feeds to the basically the plant. And usually when we talk about KGV and to measure performance, we classify KGVs under three basic categories, which are lower flow rate, middle flow rate, and higher flow rate of coal. And it's usually measured in tons per hour. Now, the methodology we used is we collect data. Of course, we need general system data. We collect processing basically about the data for the processing time for each operation and for each shop floor. We formulate a model, and then we verify, end up by validating our model, establishing also some experimental condition, and that will require from us to do some certain assumptions, analyze the interpretation, and to interpret the simulation results we get through ARENA. So the current situations is that we have millions, the total market size of 62 million US dollar of these KGVs, basically costing figures, and that shows Kickley, which is the company of our concern here, our focus, shows 14 basically million in 2011-2012, and that these data were taken also from some of the confidential reports that we signed with the company, and at the same time which shows you from year to year the lost orders of KGV due to the competition with the European products. Again, here's the average floor time. It's almost taking an average of 12.5 days now to produce a KGV using domestic manufacturers, compared to much better numbers for the European market. And so our main focus is to look at the current plant layout and how to improve that plant. Now, if we look to an overview top of the existing floor plant, you see all the sections and workshops that in this schematic top view, showing the inventory portion, integration, drilling, coating, hydraulics, and so on. What can we do with this to improve or reach the objectives we talked about in the beginning of these presentations? So this is our basically stations that go, or the stations that single piece flow concepts work with. It starts with integration, assembly, drilling, coating, fastening, and hydraulic operations, electrical, and strike test. Now, we looked at this table and we have some description for these 9 operations that we're talking about: the machine integration, the sub-assembly, and looking to the formula, the statistical process time, assuming normal distributions, and units are in minutes. And we look at the different stations, and in that same consequence we are looking at 9 stations to be described for this ARENA model. And the design also, this also will include testing and validation of process, including implementations of different flow stages, which are designs of the special trolley, laying the rails, and making one platform and testing all the stages operations, adding one by one platform, and that will basically all have some impact on time, which is unit time, which is called the TAC time, lean manufacturing terminology, to reflect the lead time. And then we lay the rails and we lay the KGVs on the rail in the process to manufacture. And here is the proposed planned layout. The proposed land layout will basically includes, and here is a top view to make it more clear. We have the these 9 stations we talked about, starting from station 1 to station 9, and we'll show now how can we basically implement these steps in order to improve. Here's a general screen for the arena model that shows the floor plan that we proposed and measuring these 3 key parameters, which are these variables: total production, work in process, and the average cycle time. With all necessary, we have run this basically model through arena, and it's running perfectly. We have used their confidential data and from Kekli, and we were able to improve and reach to basically much more better performance and quality, as we will see in the next tables. Resource details: we have all the team working on these, from engineers to welders to workers at different stations to painters to drill machines, and that will show us the scheduled time. It's almost similar timing within a difference of 5% from one station to another. Here's the average number waiting, and we've seen on each station going from one station to another, creating a queue, and the average wait or queue time, as we have studied in the arena course this semester. It will show you the average queue time in each station, station 5, station 6, and it shows also the how the sequence will also reduce the time in each station. The average queue time also, this is before and after. You see how the numbers are much lower for the drilling, coating, the hydraulic section mainly. And then here we reflected in colors the basically the scheduled utilizations at each station, and it's very apparent that, you know, while using the same manpower, still being able to produce basically reflect better utilization numbers. Here's the basically the actual percentage increase of production of KGVs using the new floor plan that we produced. It's almost an increase of 21.73%. Basically, to conclude, and that's basically will show all the cost comparison from one station to another on a monthly and hourly and yearly basis. It shows the benefits that we have achieved through the throughput time reduction, through the manpower productivity, which is over 35%. We're comparing, you know, we reduced basically the production for KGV from 12.5 days to 6.96, and also the manpower productivity and the saving and investment. It's called investments for manufacturing. We were able to save also on per year equal to the cost of these extra manufactured KGV for the same time frame. So basically, the appropriation and the simulation tool of single piece flow, while being challenging, still SPV has advantages due to its lean structure adaptability. It's basically active mostly in automobile industry, but we were able to also implement it in this type of industries, in power plants. Also, we examined the different statistical outputs. We implemented the SPV and improved the numbers as per the objectives we stated in the beginning of this presentation. Again, these phases in this projects were divided into about 4 major phases. It took about 2 months and almost 64 days continuous work to come up with this arena model and simulations. Finally, I would like to thank you for